earth like a shower of pebbles.
The man who disagreed with Democritus was Aristotle, a famous Greek philosopher. His philosophy shaped the thinking of man for the next 2,000 years, and so the idea of the atom was lost. One of the first men to explore nature's tiny realm was John Dalton, an English chemist. This was early in the 19th century. It was he who revived the idea of the atom.
I believe Democritus was right. All things are made of atoms. Take copper, for instance. My drawings show how the atoms group together. They are like little, hard, indestructible balls with some unknown force acting between them. When the atoms pack together, layer upon layer, millions upon millions, then they build a tiny crystal. And when the crystals combine, they form the copper metal we are so familiar with.
And there are also atoms for silver and gold. There are different kinds of atoms everywhere. Atoms for sulfur in a match. Atoms for carbon in every ordinary pencil. Atoms for mercury in a thermometer. A different kind of atom for each element. But most of nature's creations are mixtures. This glass is a mixture of different kinds of atoms. The wood here, another. This book is composed of more mixtures than I could name. The secret of how nature creates her mixtures was first understood in 1811 through the work of
En 1897, Joseph Thomson descubrió el electrón, una partícula aún más pequeña y ligera que el átomo más pequeño. En 1904, Thomson desarrolló un modelo atómico que establecía el electrón como un elemento constitutivo fundamental. Según este modelo, los electrones cargados negativamente están rodeados de una masa de materia cargada positivamente, similar a las pasas en la masa de un pastel. El valor científico de este modelo del pastel de pasas fue más bien insignificante, pero sirvió para tentar a los físicos a estudiar a fondo la estructura del átomo.
Evidently, the atom was not an indestructible little ball after all. But then, what was it? The first clue to this question came from Lord Ernest Rutherford of England. The year was 1911.
Today, I use the fast-flying fragments of radium as tools to probe into the atom. I placed a small sample of radium inside a solid lead block. The lead absorbed all the rays except those that were allowed to escape through a small opening in the block. One might say it was a sort of atomic gun. To make the ray bullets visible, I used a fluorescent screen. For a target, I chose a very thin leaf of gold. But to my surprise, the bullets from my atomic gun passed right through the gold leaf as though it wasn't there. It was like shooting at a ghost. This was truly amazing because the gold leaf was a solid wall, 2,000 atoms thick. So the atom can't be as solid as we always thought. Then, unexpectedly, one out of thousands of bullets ricocheted, striking something solid. I can only conclude, then, the atom is mostly empty space, like a cloud or shell. But occasionally I hit something solid. It must be very small, a tiny particle in the center. I shall call it the nucleus of the atom.
With Rutherford's discovery of the nucleus, scientists began to understand how nature builds her atoms. The shell of the atom appears solid, just as a fast-whirling fan seems solid. Actually, the shell is composed of a whirling swarm of tiny electrical particles, called electrons. They circle around the nucleus like planets around the sun. So the atom is like a tiny solar system. But scientists are ever curious. Like the fishermen who examined the vessel he had hauled ashore, they began to probe the atomic nucleus for its secrets. They found that it was composed of small particles electrically charged. They called them protons, which means primary particles. Later, to the great surprise of science, other strange particles were discovered in the nucleus. They had no electrical charge. They were neutral, and so they were called neutrons. At last, the mystery of the atom structure was solved. How amazing nature is. Think of it. There are countless solar systems of atomic suns and planets in everything. There's a whole universe in the tip of a pencil. Even in this tiny pencil dot, there are billions of times more atoms than there are people on our Earth. There are many kinds.
Para resolver este problema la tuvo en 1913 el físico danés y alumno de Rutherford, Niels Bohr. Un modelo acertado no solamente debía ser capaz de explicar la evidente estabilidad de los átomos, también debía poder describir cómo emitían luz los átomos. Por tanto, debía poder esclarecer, por ejemplo, cómo tenían lugar las líneas del espectro de hidrógeno. Este fue el punto de partida de Bohr. Clasificó las órbitas de electrones según su energía. Un radio mayor significaba más energía, uno más pequeño, menos energía. Cuando un electrón cae de una órbita exterior a una interior, pierde energía que desprende en forma fotón. Como luz de una energía específica, lo que se plasma como una línea clara en el espectro. El modelo de Bohr únicamente permite que los electrones se sitúen en las órbitas más cercanas al núcleo, donde por tanto no emiten energía. Que Bohr no pudiera fundamentar mejor estas hipótesis más o menos arbitrarias le provocó una gran desazón. Solo podía defender su modelo atómico en la medida en que coincidía con las observaciones de los físicos y pudo explicar al menos el más sencillo de todos los átomos,